Welcome in Dark Core. Do you think about the future life in the universe as an incredibly improbable occurrence for most of the elements that we now know to appear? Dozens of supernovae had to explode and neutron stars had to collide. The universe will end in either a couple of strange and mysterious ways, but what will happen to us before this and the rest of the solar system? Year 2080 probable onset of Kessler syndrome. We send about 100 rockets into space every year. Each of these rockets leaves something in orbit, a booster, a satellite, or part of a new space station. The number of objects around the Earth will grow, as will the danger of collisions. In 2009, two satellites, Iridium 33 and Cosmos 2251, collided for the first time. Such an event in the future could start the chain destruction of everything in orbit, blocking our access to space for years. And this isn't fiction, because currently the majority of maneuvers in space is evasion from debris. Year 2200, year 2200, the probable rise of human civilization to Type 2 on the Kardashev scale happens. This means that we'll begin to use energy equal to what our planet received from the Sun. Having reached this first level, we colonize Mars, Venus, Titan, Io, Ganymede, Ceres, and our moon. We will send the first ships to exoplanets that Hubble has discovered, Kepler, and in the future those which the James Webb Space Telescope and its successors find. Parallel to this, we will begin to master the extraction of metal from asteroids. The first may be the asteroid Psyche, because it contains about $700 quintillion of gold and platinum. Year 2300, sea level rises by several meters. The melting of glacier can no longer be stopped, just slow down. 4,000 years. Pole inversion may occur every 100 years. The magnetic field weakens as its north pole moves towards Siberia. If the inversion happens, the Earth's protection from radiation and ultraviolet light will drop to 10 for several hundred years. Year 10,000 years. If humanity wants to survive, it must leave the Earth. Stephen Hawking. A greater threat than climate, man-made biological disasters, and nuclear war are asteroid impact. Humanity is already preparing for this, and we have started to conduct planetary defense conference exercises on fictional asteroids associated with the likelihood of collision. The chance of survival for humanity as a whole is 5%. That's incredibly low. This is, of course, if we find a way to defend ourselves from giant space rocks, or we find other planets to colonize. In the event of a planet killer was going to wipe out the Earth. Year 17,000 years. The orientation of the Earth's tilt and the tilt itself will change, causing further change to the climate. The Sahara may turn back to the green forest. It was about 15,000 years ago. Our planet will be illuminated by the star Antares, which will explode in a supernova. For a while it will become as bright as the moon and will be seen even during the day. Year 20,000 years. This is the estimated time for super eruptions from a system of calderas like Toba, Topo, Phlegrean fields, or Gari to caldera. Year 45,000, 45,000 years. Pioneer 10 and Voyager 1 will approach the star system Gliese 445, and Voyager 2 will approach Ross 248. By this time, if we learn to travel at least twice as fast as the speed of light, we'll be able to answer the Fermi paradox. It sounds simple, so where are all the aliens? It is by this time that we will get to the farthest parts of our galaxy, which is about 105,700 light-years in diameter. During this time, we might find out whether or not there are other civilizations like ours. 50,000 years. Earth is entering a new ice age and is covered with ice. Year 5,000, 500,000 years. Humanity will reach Type 3 on the Kardashev scale and colonize the entire galaxy. Even with modern technology and sublight speeds, we will either build huge structures capable of directly collecting light from stars such as Dyson sphere ring or swarm, or will master thermonuclear fusion, which we're currently testing at the International Thermonuclear Experimental Reactor. It's quite possible that we'll be able to use the energy of antimatter, which we can already produce at the Large Hadron Collider, but in volumes of about a billionth of a gram. Year 1,000,000,280,000 years. Due to erosion, many modern stone monuments will become unrecognizable, such as the pyramids of Giza. This star, Gliese 710, will move closer to the Sun by entering the Oort cloud, the farthest belt of objects in the solar system, about a light-year away. This could cause many objects to travel towards the Sun, along with the danger of impacting the Earth. If such a collision happens, the planet may briefly acquire a thin ring of debris. By 100 million years, the Sun will become 1% brighter, causing the temperature on Earth to slowly rise. The geography will change. By this time, due to the movement of lithospheric plates, Africa will block the Mediterranean and create a Himalayan-like mountain range. India will move 150 kilometers inland to the north. Many islands and archipelagos will go underwater. Not only will our Earth change, but Saturn will lose its rings and Mars will get rings of its own. Year 5,000,000, about 200 to 500 million years. Our solar system will make a complete revolution around the center of the Milky Way, like Voyagers 1 and two which may outlive us and survive until they reach the end of the universe. If there's an end, a supercontinent will arise on Earth and disintegrate, and the brightness of the sun will begin to make the planet uninhabitable. Year 10000000. At 1 billion years, the sun will increase in luminosity by 10%, which means that the temperature of the Earth will rise 47 degrees Celsius. Several hundred million years earlier, photosynthesis on the planet will disappear due to the fall of CO2 levels in the atmosphere. Along with the plants, all animals will die, and the oceans will quickly begin to evaporate. Only small remnants of the seas will be the last refuge of primitive life on the planet. Year 250000002.5 billion years. The Andromeda Galaxy will collide with our galaxy. It does not threaten the planets of the solar system. By this time, the Earth will lose its magnetic fields due to the solidification of the core. The temperature on it will increase 150 degrees Celsius even at the poles, and the increasing distance to the moon will leave a solar eclipse in the past and destabilize the rotation of the planet. Year 450000004.5 billion years. The Earth will become hotter than current-day Venus thanks to water vapor and reach thousands of degrees Celsius. Year 650000006.5 billion years. Mars will begin to receive as much energy from the sun as current-day Earth. This will make it easier for us to terraform and create a second Earth from the red planet. The sun itself, after burning up its reserves of hydrogen, will begin to grow larger. As it expands, our star will move the habitable zone to the moons of Saturn. Year 67,006.6 to 7 billion years. The sun's core bursts into flames when the helium in it begins to convert to carbon and oxygen. The sun will not explode like a supernova, but for a short moment it will become brighter than all the stars in the galaxy combined. 8 billion years. The sun's core will become a white dwarf, dense and compact coal with a very low temperature. The star will lose about half of its weight along with the shell. 22 billion years. The first hypothetical scenario of the end of the universe. The universe is expanding at an accelerated rate, and scientists believe a reason for this is dark energy. In simple terms, it pushes everything away from itself, working as anti-gravity, expanding the space with sufficient strength. Dark energy will begin to distance not only galaxies from each other, but also the atoms and molecules themselves. This will lead to a big rip when everything in the universe is split into elementary particles. Otherwise, if dark energy is weakened, then everything in the universe will begin to converge due to gravity and eventually will be swallowed up by huge black holes. Modern scientists argue that dark energy is very stable, and so far neither a big gap or a big collapse awaits us by the first trillion years. All year 230000000 galaxies closest to ours will collide into one supergalaxy, and all the rest will begin to move away so much that we can no longer observe them. The same will happen with the cosmic microwave background radiation, which will cool down and become unobservable. Without technology, most of the stars will die before this time. The largest of them will have the shortest life, having exploded in supernovae, and red and brown dwarfs will burn their fuel the longest, 100 trillion years. The end of the stellar age. Only rare collisions of the remains of luminaries such as dwarfs and neutron stars can create something new, but just for a short time. All the rest will begin to slowly turn into black dwarf. The dimmest and coldest stars and even neutron stars will begin to slow down their rotation. Galaxies will begin to disintegrate or have already disintegrated, and the remaining planets will be thrown out of their orbits due to flying past the remains of stars for tens of quintillion years. Nothing happens in the universe except the absorption of black holes into each other. If humanity can survive until this time, they will become the last source of energy for us, like neutron stars, but at 3 times 10 to the 32nd power of years. A proton presumably will decay with its disintegration. All ordinary matter will cease to exist. If that doesn't happen, not much will change. All black dwarfs, after many trillions of years, will begin to turn into iron dwarfs, and then into black holes. One way or another, the universe will represent only a huge field of black holes, most often so far from each other that it will be impossible to detect them. After time, the true end of the universe will begin with the evaporation of the first black hole by about undecillion years. 2 times 10 to the 66th power. Due to Hawking radiation, nothing in the universe will last forever. The most massive black holes will take thousands of trillions of years to evaporate. Time after time, the universe will be illuminated for a very short moment by dim explosions of evaporating black holes. When there's nothing left in the universe, absolutely nothing, it's quite likely that the last thing that is fundamentally capable of this, the vacuum itself, will begin to disintegrate. The entire vacuum in the universe has some kind of energy. At a moment in time, it's possible that any energy will fall to its zero possible level. This will provoke a chain reaction spreading with the speed of light, disintegrating everything around. It is likely that this has already happened somewhere in the universe. When billions, trillions, quadrillions of years have passed, there may be many hotbeds of such decay, and as a result, they will evaporate absolutely everything. Leaving the universe in a complete zero energy level will happen after that. We do not yet have ideas or even any acceptable theories. Perhaps the universe has somehow spawned progeny, creating a multiverse. Perhaps it will eventually collapse and repeat the whole cycle again. We do not know. Our existence in itself is a great fortune, so it's worth taking everything from life, watching the beautiful starry sky while it's still bright and full of energy. Thanks for watching. Cool.